Here's my preferred way to learn how to work out the length of an arc. First of all, what's the perimeter of a circle? That's 2 pi r. If you don't know that, probably go away and learn a bit about that first. If you're comfortable with that, okay. Next thing, what if we just want this arc, which is just half of a circle? Well, then the arc length must be a half times 2 pi r, obviously. What about this one? Well, that's just a quarter, yeah? Obviously, so this all makes sense so far. What if it's just 1 degree? Oh, well then it's obviously just like 1/360th, because there's 360 degrees in a circle. So that makes sense. And what if, final thought, what if it's 17 degrees? Well, it's obviously just 17 over 360, because that's like the fraction of a circle that you've got, times 2 pi r. So I recommend using this equation. I'll just put a circle around it. That's the length of an arc. X over 360 times 2 pi r. I know there's other equations out there, and some say, oh well, my equation's simpler because for example, you might simplify this already and just call it 180, and then learn the simpler one. No, I say don't do that, because this is easier to remember, and it's also, you can then apply this in other situations. So there's like 3 reasons I like this, if not more. It's easy to remember. The second reason is we can use it in different ways. So I just write use different ways. We're about to see one of the other ways you can use it. And the third thing is we're learning about fractions. Fractions are so important in advanced level mathematics. We use them a lot in setting up questions or answers, solutions. A fraction enables us just to use like part of an answer, and this is starting that learning now. It's a transferable skill as opposed to just learning a short equation which you can't really use anywhere else in maths. Let's get on with this. Second one. Now the problem with this second one is I just need to undo all the writing I did over the top here, so just quickly do that. There we go. Right. The second thing is, this is an example of how we can reuse the first equation. Just one example of how we can reuse it. I've scribbled out perimeter and I've written area everywhere. Can you see that? So then the final answer is to do with the area of a sector. And I mean, you can look through. Obviously we've changed 2 pi r to be pi r squared, but apart from that all the logic stays the same, and look, we've got a new equation. The area of a sector is x over 360 times pi r squared. We're already getting benefit from the fact that we're going to just use an equation which involves fractionally more writing but is more applicable in different areas. That was a lot of waffling. Basically, that's your arc length there, and that's your sector area there.